from Ukraine. I'm from Poland, so I won't be speaking Russian. That would be probably scary, as you could hear, right? And additionally, with the tool here, in which I feel like I'm going to have a tooth operation in a second, it's really hard. So that would be very stressing. Okay, so I will be talking about Agile Design and how I see a role of design in Agile software development. My name is Paul Lipinski. I lead a software development company in Warsaw. It's a little Java software house with 10 people. And it's pretty new one, it's 3 years old. And before that I was working as a software architect for a few companies, including very big companies. And I was also working, and I'm currently working as an Agile coach. So I had a chance to visit quite a few different projects and see how design and architecture impacted the later performance of teams, and I could see how even good developers couldn't manage with the applications they were developing because of the design decisions and architectural decisions they have been making. I'm also doing test-driven development coaching. I even had my training the last 2 days here. So partially, if anybody of you has been here on the previous session, it probably will relate to what has been said in the previous session. So let's start with Agile Design. Where do you see design here? Is there anybody here who can see a design or architecture somewhere here in the picture? Probably not. Because in Agile software development, especially probably the last few years, Scrum has been the most popular framework and the most popular method of Agile software development. And Scrum doesn't say anything about any practice. Scrum even says that it's not about software development, it's basically about any project management. It's just a project management framework, which is fine. The problem is that because it has been so popular and because so many people have believed that Scrum will save their projects, and many people believe that the process itself is basically enough to make a good team, or a process itself is enough to make a good product. And because of that, I've seen many teams not performing very well, and many teams not really being happy with what they have been achieving. But if the team is not happy with what they're achieving, it is a problem, but maybe it's not the biggest problem. The biggest problem is if the customer is not happy with what the team is doing, right? So, and I can see that we're slowly going towards including more and more software development practices into our Agile toolkit. And during this year's Agile conference back in September, here in Kiev, on the closing keynote, J.B. Rainsberger said, he had a keynote with something like, what is Agile 2.0, what is Scrum 2.0, where are we going, what's the direction? And he said, he claimed that he can see that Scrum 2.0 is basically this. It's extreme programming. Because if you look at the extreme programming from and this is XP days, right? So I shouldn't be showing the previous slide. That was a heresy, sorry. So this is the main slide, right? And because more and more teams see that it's so important to include practices like test-driven development, continuous integration, continuous delivery, pair programming, and stuff like this into their way of working, and not only the soft side of software development, like the process and review and planning and retrospective being the softest of all the practices. More and more And from the process perspective, XP is really not that far from what we know from Scrum. So basically, what's the difference if you look at the previous picture and this picture? I can see some word that rings my bell here. Architectural spike. So basically, any XP project starts with, not only as in Scrum, we say that a project should start with a rough idea of what we're going to do, right? With a vision of the product, and then based on the vision, we elaborate on user stories. In XP, we not only do we elaborate on user stories, so the soft side, the analytical side, but we also, in order, you see, before we do any planning, so before we are able to give confident estimates, we need to get some architecture. We need to know in what model we're going to be developing the software. And that was called extreme programming, right? So this was supposed to not to have any design, as people say, no documentation and total chaos. So you can see this is not chaos. We're starting not only with a vision based in user stories, so probably not only a vision, but a more detailed idea of what are we going to achieve. But also we're starting with an architecture, with an idea of where we are going also from the technical perspective. And once we have this, we can be giving estimates on unknown architecture and oftentimes unknown domain. You know how it is called? It's called a lie. Basically, we are lying. And actually, we all know we're lying, right? Because who feels confident about estimating a new project? Hands up. Who feels confident? Thank you. I will launch in my company, okay? You will be signing the papers. Okay, yes, nobody feels confident because we don't know. So, you know, the classical methods have been coming up with extremely complex models for estimating. Anybody of you have heard of a COCOMO model of estimation? Yeah, one person, or two people, right? COCOMO model is based on a mathematical formula that's probably as long as this. It's just, nobody can comprehend it. With a lot of magical factors like 1.37, I don't know what that means. But basically it's based on some factors which have been found working or not working, but a lot of people got their Doctor of Philosophy because of these factors. But basically we don't feel confident about this. So in XP we start with an idea of stories, with an idea of architecture, and we are doing spikes. You know what a spike is in XP? Spike is a time box that you sacrifice, that you spend on evaluating a topic. And it's not sitting and reading documentation, though it can be, but mainly it's sitting and verifying whether my approach, my idea is going, where is it getting me? So it's about deepening your knowledge about the user stories, and it's about verifying your assumptions about the architecture, so that you are able to see what is possible, right, within the domain that you have and the architecture. So the idea for this presentation is, I wanted, because this is Agile Design, so I wanted to map these two things, right? So one thing is everybody knows that, right? Agile Manifesto principles. So these are values, but mainly Agile Manifesto principles. So what we believe is true in software development, to the design stuff, to the technical parts. So I have taken, I won't be going through all of them. That would probably put half of you to sleep within the first 5 minutes and the rest within the next 5 minutes. But I will try to show you how's one related to the other. So, I just took those that are really related to the technical side. So our highest priority is to satisfy the customer through early and continuous delivery of valuable software. Does anybody here see any contradiction? Early and continuous. Isn't early and continuous in contradiction? Many times it is. Because if we want to deliver something fast, what is the thing that we sacrifice? Ideas? Quality, sure. We sacrifice quality. The first thing that we are able to sacrifice is quality. Because initially nobody sees it, right? Because it's only we who know it, and most probably even we don't know it. I mean, you know, these are so little things. I'll just skip the test here. There's a little duplication here, but you know, that's just one for loop, right? And you know, these things are similar, but if I use this here, I wouldn't be able to use it there. So these are decisions like this that, if not taken seriously, if not taken with full responsibility of what you're doing, are leading to a system which maybe is the first version is created indeed very fast, but the result may be not very good. And then if you want to do a continuous delivery of such a system, it's just impossible. You will have to stop at some point and say, you know what, guys, now we need a refactoring iteration, right? Who knows refactoring iterations? Oh, really? Yeah, so it's called refactoring iteration, and you know what happens usually after refactoring iteration?
Fixing iteration.
Yes, exactly, because we are introducing new bugs. Because who's using automated refactoring, right? Automated refactoring software girls. Excuse me, girls. So basically, we like to take the risk as software developers. The problem is it's not our risk, it's the risk of the users and the customers. So, in order to be able to continuously deliver software, the early version of the software, the thing that we are starting with, must already be well designed, and it already must have a rough idea of what we're aiming at. And I'm not talking about a huge final definition of the architecture and all the little pieces of code as it is in some software development methods. I'm just talking about finding the most probable path on one hand, and on the other hand, developing software in such a way that you will be able to modify it. So, so basically what we're doing here when trying to release something fast is usually taking a technical debt. And I would like to tell you now a story about two projects I have participated in. That was a good few years ago, and that was before I started using test-driven development. The first was a software that I was writing together with my colleague for an insurance company for the call center. So that was a tool for telephony computer integration, so that people in the call center could answer their phones from the computer. That was pretty complex because we had to code all the telephony related events logic. And the problem was that the company I was working for that time has won the project because we promised that the whole tool will be ready in, I don't remember, 3 or 4 weeks. Right? It's easy, isn't it? So we have sat down to write it, and because the deadline was really sharp, because they have, before signing the contract, the customer has already informed the press and the PR started that they will be the first direct insurance company on the market. You know, there was no other way but to do it. So, what I did, my colleague was responsible for the server side and administrative side, and because I use Swing and he didn't, I took the software phone side and the telephony side. And unfortunately, very soon, it appeared that, I know nothing about communications. Basically nothing. I even didn't know it's so complex. I just thought it's, answer the phone, put down put it down, and that's it. And apparently it's much harder. You need to transfer to somebody else. You need to mute the person. You need to, sometimes you talk and the battery in the mobile phone of the person goes down, and the whole system doesn't know what's happening, and stuff like this. So there's a lot of different events. And one event can be followed by another one, but I started with a, simplest thing that could possibly work, being, answer phone, put it down. So, I had a little switch on the events with the first switch is the event saying, the telephone's ringing, the other one, we hung up. And then I was developing this great idea of switch. After 3 weeks, or I don't remember exactly what the period was, I had a 1,500 lines long switch. And obviously, we delivered by the date. So it was early. And obviously, for the next 2 months, I was sitting together in this call center with 200 people using this application, cursing and swearing at me all the time because it just wasn't working. I mean, it was working in 80% of time, but 20% is annoying enough to, they just couldn't work. So for the next 2 months I was fixing bugs, and obviously the company I was working for wasn't paid for this. So it probably wasn't, from the economy perspective, such a good deal. 3 weeks for 2 months of fixing them, right? So was it valuable? I mean, it was given by the date. But again, the valuable, it may mean different things for different people, right? And so that's one project that and the follow-up was somebody found this code in my company, found this code in SVN, and then it was printed out on papers in the office, everywhere. So when I came after, because that was June, then I went for vacation, I came after vacation, I could see the whole office with the printouts of my beautiful code and my class called business process. And that time, because sometimes you need to really hit the bottom to be able to jump up, right? So that was for me hitting the bottom, and I decided, I will never ever in the future to be ashamed of my code, right? And probably, obviously, it wasn't never ever, but at least I started to find ways to develop software better, and that was how I found test-driven development. So this is something that you need to look at, even if that one thing more that I learned during that project. I learned that I'm a bloody chicken. I'm just a coward. I wasn't brave enough to say, it's not doable in that time. I'm just not going to take responsibility for this, right? So that's another thing which probably you need to learn at some point. One has to grow up, right? So that's one thing. So I encourage you very much to always listen. When I'm giving trainings and when I'm working as a coach, I often tell the teams, not listen to your heart, listen to your stomach, because that's a very good, at least maybe because I'm a man and stomach is pretty important for men. I find this organ in my body extremely responsive to different situations, and whenever I don't feel confident and whenever I don't feel sure about something, this is the place where I feel it. So now, whenever there's a stressful situation, I'm trying to listen to my stomach. Okay, the next thing is welcome changing requirements even late in development. blah, blah, blah. Yes. So, what does it really mean? How are we able to be welcoming changing of requirements late? You know, even if we make you know, normally people say yes, if we don't do big design upfront, then we will be able to meet changing requirements, right? Obviously this is not true, because it's not related to whether you did the design or you did not the design. It's related to what your current design is at the point that you need to make a change. So if you did a great deal of big upfront design and it was lousy, and then everything is great, maybe, then you know, then you can welcome changing requirements. If you didn't do anything, but your design is very bad, you will not be able to welcome anything. You will probably be said farewell at some point. So, so the possibility to be able to welcome changing requirements is related to a few factors. One of them is the scale of the project. If we're talking about very big projects, it's basically impossible. I don't know what's your experience. My experience is it's absolutely impossible to write a big project without really architecturing it and without designing it. It's just absolutely impossible to be later able to respond to what's happening without a preparation of the project to it and without proper designing on the way as we're developing the software. So what we need to focus on, the main thing that we need to focus on is modularity. And this is related to what was being said before. The solid principles on the low level have a great impact on modularity. They have a great impact on modularity on the object level. If you try to keep the rules, or these are not rules, they are also not principles. This is heuristics of design. If you try to keep them reasonably, your chances for having a modular project that is able to be developed later are much higher. From the architectural perspective, if you look at successful projects, successful huge projects, you probably, maybe except for Linux kernel, you won't find a project that is not very highly modular. And since I remember Linux kernel from version 2.0, maybe they have changed that. That time it wasn't very modular. But all the big projects that I know, starting with Eclipse platform, are extremely modular. Whether they have made good decisions or bad decisions in details is a different story. But I would say Eclipse platform is developing pretty nice, right? And how many years it is? Probably over 10 years, something like 10 years that it's being developed by probably hundreds of different people. So that's something, and it's probably being, the requirements, it's not only that new requirements are coming, I'm pretty sure they are also changing the things that they had. Knowing, for example, JUnit source code, I know that they must have be doing in the JUnit plugins, they must be doing changes in the JUnit plugins probably every day. So maybe every week. So they are welcoming changing requirements. But this is because of the modularity, because it's not that whenever you touch a system here, everything blows up there, right? Modularity is also extremely important when you have a long-lasting project. My other story of a project is a project that currently my company is doing. I have started a company with this project, and it's currently nearly 3 years that we're developing it. And what we started with was, how to make it. We knew it would take some time. Now the project is probably 300,000 lines of code, so it's pretty. At least it's not a small project. And so what we have decided at the very beginning is to really make it modular, and to make it so that each element can be pretty easily modified without touching other stuff. So we are now after nearly 3 years of development. Yes, obviously it's completely different to this project 6 years ago, because we started with test-driven development from the very beginning. We started with pair programming from the very beginning, and the whole company culture is towards focusing on quality first. So it must be different. On the other hand, that project, I was able to write it in 3 or 4 weeks, and this one, me and my colleague, and this one is being written by 7 people over 3 years. So it's also a different in scale. And this one is probably the best quality of the code I have ever seen in a big project, and that one was probably the worst. So the next question is, when is the last responsible moment for the architecture? So when is it that we need to make, because architecture is usually defined as the things that are very hard to change later. So when is the moment that we need to make the decisions? Yesterday? Good answer.
Before coding.
Before coding? Probably the answer isn't that easy. You need to make some decisions early, but you always want to be able to change them. Obviously, there will be decisions that will be extremely hard to change. If you have decided to base the whole application on some architectural pattern, like all the components will be stateless, and all the components, in order to exchange something, they need to communicate over one database, and each of them doesn't know anything about each other, it will influence your decisions later, and probably changing this after 2 years of software development will be hard, right? So you need to abstract from the architectural decisions in your code in such a way that you always leave yourself a possibility to make changes. And this is why things like single responsibility principle, dependency inversion principle, and interface segregation principle are so important, because they three talk about segregating the responsibility. So if you have a responsibility which is business-related responsibility of your project, if you connect it to the technical responsibilities, like how to store information in the system, you will not be able to modify the way you're storing information of the system without touching the business. That's why I try to always cover your logic with abstractions that will abstract your logic from the way the things work on the technical side. So this architectural spike in XP and in unified process, it's pretty the same. The first part is called an elaboration part. The idea about the first phases, the beginning of the project, is really not to have a curved in stone, cut in stone architecture that will never change. The idea is to minimize the risk of making mistakes. So it's not about putting down everything on the paper so that developers can then hear the God's word and know how to code finally. The idea is that during the phase, sometimes it's called iteration 0 in Scrum, we should focus on cutting our paths through the system so that we touch all the main modules of the system that we know of, that there will be, so that later we have a kind of a skeleton of the architecture. If any of you has read the book Growing Object-Oriented Software Driven by Tests, the authors tell there about a walking skeleton, which is a very narrow slice through the system of only a little functionality that verifies that all the layers cooperate and that the whole architecture works fine in order to achieve a given functionality. So basically you need to, during this phase, you should make a lot of these little walking skeletons through the system to see, to get the overall vision, to minimize the risk that something is just not doable because of something, right? If you are able to cut through the system with one functionality, the probability that you will be able to do that with others is pretty high. If you haven't checked, you don't know. So it's also very important to organize the first user stories that you touch. Excuse me, I don't want to spoil anything. The first user stories that you're taking into iteration to take the ones that are really best fits for this, and which ones are the best fit. If you listen to people, to the business-oriented Agile people, they will tell you value, customer value is the most important thing. If you listen to the technical guys, they will tell you, you know, it's great to have a good value in the system. Yes, it is important because otherwise the system is just, we need to, in order to release something early, it must be valuable. But what we really need to have from the technological perspective is risk. So we should take the ones that have the highest risk, because the ones that have the highest risk influence us and our velocity, our timing, our pace later on. So I would say from architectural and design perspective, take those which have the highest risk first. The second thing would probably be the value as well, but I would add another one, which is the coverage. So even if you have a few that you think have highest risk, you have a few that have high value from the customer perspective, you also need to look at those that maybe are not that valuable, maybe they are not that risky from your current perception, but they let you cover the whole system as you imagine it. So that you can really cut through all the elements to see what's the skeleton of the system. So that when you have this, you can also more easily grow your team, because then people know how to work in that system. When I'm doing test-driven development trainings, I can very often see, I could see that yesterday. When I give an exercise to do, which is just in terms of what I would expect the code to be doing, and I don't give any code for this, it's very often that, you know, people just sit and, what should we be doing? You know, you should do this, right? Try to make something like this that works. And so you need to give them, and you know, the response is basically nothing. And then I try to draw, a few blocks how I imagine this to be done, right? The 3-4 blocks, and then it's clear. So if you cut through all these ways through the system, it will be much easier for people who then join the project to see, you know, this is the way to work with that system. Okay, deliver working software frequently is extremely important, obviously, and from a couple of weeks to a couple of months. So basically, I don't know why they wrote a couple of months. It's probably because it was 10 years ago. Currently, we're in the lean startup times, right? So everybody wants to deliver 15 times a day. And is it possible to deliver? There are companies who do this, right? So what is required to be able to deliver many times a day? Quality. And a lot of tests, because, you know, you're not able to deliver 15 times a day with manual testing. Regression testing of the whole platform, right? So lots of tests, different tests, all acceptance tests, infrastructure and integration tests, and unit tests. Otherwise, no way. So you may think that this is only for startups. in our system, we really deliver to production. Yes, we deliver probably, I think it's like 1 month. I even don't know because we don't care. It's important from the perspective of chain management, which is create package all the time. But the culture is to have the same quality with every release, so that every commit that goes to the source code management system, every commit is at the level that the package, which is then built by continuous integration, you can just take it and install in production, right? So whether you have the pipeline to automatically install it, or you have 15 people in India who do change management, that's a choice of your customer. But basically, the most important is the culture. Because if you, like in our company, in our project that we're doing, we have a tester on our customer side who from time to time wants to test something. They always have the current version. It's probably 1 hour old. The next thing is simplicity. So this is probably our greatest sin in testing. We try to keep the code clean, to not have the McCabe's complexity measure more than 3 per method. But the design sucks many times. So what's important, I think, is that if you look at people who were doing extreme programming, who are involved in the extreme programming movement, and the books that they have been writing, there are not that many books which are not on design patterns, in a way. If you look at Martin Fowler, it's like probably 3 books on different design patterns. If you look at Joshua Kirievsky, if you look at even Ken Beck's work, if you look at even Uncle Bob was working with design. But basically all these people were involved in actually the whole XP programming movement in a way started up from the design patterns groups, and top conferences. So in feature-driven development, there's an idea of, in XP there's this idea of YAGNI, you ain't gonna need it. So the answer of feature-driven development was JEDI, just enough design initially. So they are JEDI. Okay, what do you mean? Okay, so the question is, what's the goal? How many minutes do I have? I don't have any more. Okay, that's fine. What's the real goal of designing? That's the main question. Why do we want to design? Why do we want to work on design? So there are 2 answers. Yes, we want to minimize the risk. I was talking about this earlier. Because the better we know what we're doing, the less is the risk during the development that we will do something wrong. And obviously I'm not talking about the big design and the whole system to the littlest, small, tiniest detail of, drawing sequence diagrams showing all the paths so that developers just need to map the diagrams to for loops and ifs. I'm talking about the overall general view of the system, and mainly I'm talking about the domain modeling. Domain modeling is the most important thing because it deepens your understanding of on one side of the domain. On the other side, it deepens your understanding of the relationships of in the system and how to organize it so that it fulfills the responsibilities. So normally in object-oriented design, people, if you look at Wikipedia articles, if you in universities, everybody's talking about polymorphism, information hiding, abstraction, stuff like this. But what I think is the most important, it's not my idea, it's probably, it's Rebecca Worth-Brock's idea, or quota, is the responsibility. So, yes, these things are elements that are used to get the objects working, but what we really want to do during object-oriented modeling and design is distribute responsibilities among the objects. So, find the objects that we would like to have in the system that make sense and distribute the responsibility. So what's the best way to do this? There's one really nice practice in XP which is probably, I'm not sure, how many of you have ever heard of CRC cards? Okay, a few. This was a way of doing domain modeling in extreme programming teams some time ago. If you look at early books, this is or articles, this is how people were doing this, and this is a great way of designing. CRC cards are cards on which there is an object or a class name. So initially, you go through the user stories that you have, and you try to find entities, and you describe them on cards. Once you have the entities, you look again at the user stories, and you try to assign responsibilities to the entities. So you distribute among these entities the responsibilities so that it seems reasonable. And then you're trying to assign which object is related to which one, or actually you probably do it all of this at the same time. You're trying to relate the objects, so you're trying to find collaborators. So this is class responsibility collaboration card. So you try to find which objects collaborate with which objects in the system. So that what you really get is a network of objects that result in a functionality that you're looking for. What's even more important that during this discussion with CRC cards, what very often comes out is what you really need is you need contextual models. It's not that the whole system has one class called, I don't know, an order, for example, right? In most situations, in bigger systems, if you had only one class like this, it would probably have like 30 methods. And would all the places where this class is used use all the 20 methods? No. So here we're again touching this, the principle of, forgot the name. Anyways, one of the solid principles. Not list of, yet. Iterative segregation principle. So you need to have, in order to have a good interface segregation principle, it's not only about giving different views to the same class. From object-oriented programming perspective is sometimes having the same logical entity in many places of the system with different responsibilities, sometimes different set of data, a little bit different subset of the overall state, so that different customers can have their APIs and their way of working with the entity that is most convenient. I'm finished. Okay, the last thing is I wanted to talk about is at regular intervals the team reflects on how to become more effective. So basically this is about retrospectives, which are a great thing for building teams. But retrospectives are also a great way of reflecting on the design, of thinking where we are in our design. Because it's so easy when you're working and you have the end of iteration soon. It's so easy to forget about, to make this, to be forgetting, this test, that test, to lose the general picture. You're focusing on details to implement a functionality, and you're losing the general picture. And very seldom you have a possibility to really sit with the whole team and look at the project and think, is this what we wanted to achieve? Is this what we want to work with? But in order to be able, it's good to have the discussions when you can do something about this, otherwise it's just frustration. So if you have good tests, if you have a good framework in which you can modify the design when you need it, then these discussions really make sense. So basically there's one quote which you probably know of Eisenhower. I'm not Eisenhower, and I wanted to make it little because I'm probably not as big human being as he was, but otherwise you wouldn't see it. So there's my quote which I just prepared for this session. Basically, I encourage you to do design. I encourage you to work in your teams, especially within the team, not one person, on your designs, to discuss your designs and architecture on the application level, to see whether you are really thinking about distributing responsibilities or you're just having all the data access objects in one great package and you have 80 of them in how to work with it. So try to work on the functional basis and then try to work with your team on the responsibilities basis and try to map that to the technology you're working with. And think of designing as a process. So as you make decisions during retrospectives or other design meetings, you're making decisions, but remember this is not it, the whole map. You can change them later on. If some decision feels inappropriate at some point, you can change it, discuss it. Thank you very much. I hope